be starting in a bit. Okay, let's continue. I believe everyone is here. Okay, let's continue. Let me write the theorem. Let's start with the theorem. Okay, so the theorem says if two equal chords of a circle intersect within the circle, prove that the segments of one chord are equal to corresponding segments of the other chord. Okay, this is the theorem which we are having and we have to prove. Let's understand what exactly the theorem says. So here it's written over there, if two chords of a circle intersect within the circle. So we are having a circle. Here it's written that two equal chords are there. So let's say we are having equal chord, that is AB and MN. Why I am drawing chords like this? Because it is written here that intersect within the circles. So the chords which are equal in length are intersecting. Okay, so it is given that AB is equals to MN. It is given over here and we have to prove, okay, let's see what we have to prove. We have to prove that segment of one chord are equal to corresponding segment of other chord. What is the meaning of that? Can you see both chord are getting cutted? That means this segment, this yellow one, the bigger part of the first chord AB is equals to the bigger part of the second chord MN. Okay, the segment of first chord, the bigger part is equals to the bigger part over here, and the smaller part of the chords are also equal with each other. That's what we have to prove, that this green one and this green one are of equal length. Again I am repeating, we are having a circle where two equal chords are there, both the chords are intersecting each other. We have to prove that the bigger segment over here is equals to bigger segment of the other chord. We also have to prove that the smaller part of the first chord is equals to smaller part of the second chord. Okay, you can see here it is written clearly that the corresponding segments are equal, we have to prove. Okay, let's do that. So we can do one construction over here. Before that, we can do one thing over here. That is, it is given that AB is equals to MT. Let's say this is the point T. Here we are having T. Here we are having point T. Point of intersection is point T. Here we are having the center O. Okay. Now let's see what can we do. So we have to prove that. To prove that the yellow one, that is 80, is equals to the yellow one over here, that is NT. And we also have to prove that the green one over here, MT, is equals to the green one over there, that is BT. Okay. Now let's see how can we do so. So first thing first, we will be dropping a perpendicular on the chord MN. Okay, I am dropping a perpendicular on the chord MN, and I am saying that this perpendicular is bisecting the chord MN. Okay, if this is the point S, then I will say that MS and NS both will be same. Why? Because perpendicular drawn from the center on the chord bisect the chord. Let's write it. We are dropping a perpendicular. OS is perpendicular on the chord MN. Therefore, MS is equals to NS. Here you need to write the theorem. Perpendicular drop from the center on the chord bisect the chord. Similarly, I would say we will be dropping a perpendicular on the other chord AB also. Okay, perpendicular. And we will say that this perpendicular is bisecting the chord AB. Okay, so we will say that OP is perpendicular on the chord AB. Therefore, we got the middle point as a P. So AP and BP will be same. Is it clear so far? This is equation number 1. This is equation number 2. Is it clear so far?
Yes, ma'am.
Okay. Now here we know that chord AB and chord MN are of same length. That means half of AB and half of MN both will also be same. Yes, it will be. Now what we can say here, half of AB means, can I say AP, and half of MN means, can we say NS? Why I am saying AP and NS over here? Because we want to take the yellow part only, both side. Okay. So here I have taken AP, there I have taken NS. If you are still not sure, you can see over here that here we have written NS, MS, both are same and both are equals to half of MN. Here we have written AP, BP, both are same and both are equals to half of AB. Okay. So when we are talking about half of AB, half of MN, we can say from this two equation, all are equal with each other. Can we say, rather than writing like this, let me write something from here. Now, MS, NS is equals to, both are equal and both are half of MN. I am writing it over here. AP, BP both are equal and both are half of AB. That's what I can write over here. Right? Now we can say, since AB is equals to MN, both the chord are of same length. That means half of AB and half of MN will also be same. Okay. This was already given. I am not writing by myself. ABMN was given as the same. I am just copy pasting from here. You can see. Now we can write over here that half of AB means I can write AP, or maybe I can write BP. Half of MN means I can write MS, or maybe I can write NS. So eventually all are equal with each other. Can we say? Can we? From equation 1 and 2? Is it clear so far? Is it?
Yes, sir.
Now we will be doing one construction over here, and we are joining OT. Okay, we are joining OT. Now we will be taking two triangle over here. This two triangle, you can see we can take triangle SOT and triangle POT. Here we can say what is same in this two triangle. So we can say SOT and POT. Just concentrate over here. There is 90°. Here is also 90°. So we can say that angle OST is equals to angle OPT. Both are 90. We can also see here OT and there OT. Both are common side. What else we can say? Can we say OS over here is equals to OP over here? Why we will say that? Equal chord are equidistant from the center. Yesterday only we have discussed this theorem. Equal chord are equal distance, having equal distance from the center. So let's write equal chord are equidistant from center. Okay, these are the three conditions we have got. Now if you will focus over here, you will be able to find that RHS congruency is working here, and hence triangle SOT, triangle POT are congruent. So we can say that triangle SOT is congruent with triangle POT by RHS congruency. Now from here we can say that STPT will be equal by CPCT. Still our focus is to prove this two yellow shaded, yellow highlighted length are same and green highlighted length are equal with each other. That's what we want to prove here. We have got that ST is equals to PT. You can see the yellow part ST, the yellow part PT. These two are equal with each other. That's what we have got from CPCT. Okay, now equation, if this is equation number 3, then we have to use equation 4 and equation 3, and we have to do something so that we will be able to prove. So can we say that ST plus NS, ST plus NS? How I'm writing NS? Like suddenly, all of sudden, because ST is the yellow part, the another yellow part is NS. If total all together will be equals to all together yellow over there, then we can say that what we wanted to prove, AT is equals to NT. Yeah, AT is equals to NT, the yellow parts. Okay, so I have taken ST plus NS. Now I will take PT. I am using equation 4. Okay, I am taking PT plus another yellow part is AP. What we are doing? We are adding equation 4 plus equation 3. In equation 3, AP, BP, MS, NS all are same. So what we have taken, NS we have taken and AP we have taken. This two we have added with this equation. What we are doing? we are doing that ST and PT both are same. This one we have got by CPCT. ST, PT are same. We have already got by CPCT. Now I want to add something over here and want to add something over here. So that we will get the both the yellow side same or maybe both the green side same. Okay. Now there is a Euclid's theorem which says that if equal are there, ST, PT are equal. If you will add equal to it, the remaining and the whole will be equal. Okay, the Euclid says that if ST and PT both are equal, sitting on the seesaw, both are equal, and if you will add something over here, you will add same thing over here, the whole will again be equal. That's what Euclid has said. Okay, so I am adding NS over here and I am adding AP over here. Why? Because NS and AP both are equal. You can check over here. NS, AP, both are equal with each other. Can you see? Why NS and AP only? Because ST means what? ST means we have got this much part. But I want the whole yellow part. So that's why I have taken NS. Now ST is equals to PT we have got from the CPCT. That means PT we have got. But still if I will have AP, then and only then we will be having the complete yellow one. So AP I will be adding. But directly can we do like that suddenly without any reason, without giving any proper explanation? Can we do? Yes, we can do. Because AP and NS both are same. You can see here AP and NS both are same. We have written already in equation number 3. That means we are adding equal with the equal. Something which was already equal, we are adding equal to it, and again it will be equal. Or from here you can say there is a equation which is AP is equals to NS, or you can say there is a equation from here. From equation number 3, one more equation we can make. That means NS is equals to AP. We can make this equation from equation number 3. We can say this is equation 3 star. Okay. Now we are just adding 3 star and we are adding it with 4. Okay, 4, equation number 4 you can see here. Equation number 4 is this one, and we are adding 3 star with it. What is 3 star? NS is equals to AP. Okay, we are adding 4 with 3 star. So ST plus NS is equals to PT plus AP. Now let's check what is ST plus NS. Let's check it. What is ST plus NS? Let's see. ST plus NS is NT. Can we say ST plus NS is NT and AP plus PT is AT? Can we say ST plus NS is NT and AP plus PT is AT? Okay. So this is NT and this is AT, and this is what we wanted to prove. Can you see? Here I have written in the proof part AT is equals to NT. Can you see? Are you getting it?
Yes, ma'am.
Similarly, we will be able to prove these two green parts are same. How? Again, by taking the same equation. ST and T, ST, both are same by CPCT, which we have written over here. Okay, let me wipe this one. Now From equation number 3, can I say that ms is equals to bp? ms is equals to bp. Yes, we can say all were equal with each other, so we can say ms and bp are equal. That is 3. If you want, you can say 3 double star, or directly you can say we have taken it from equation number 3. Okay, ms is equals to bp. I am writing it. ms is equals to bp. We have taken it from 3. We are having equation number 4 as st is equals to pt. So I would say ms minus st is equals to bp minus pt. We are subtracting equation number 4 from equation number 3. Let's get back to the figure and let's see what is ms minus st. Can you see ms means this total, minus st means this part is not there. That means empty only. Can I write empty? ms minus st is empty. Can I write?
Yes, ma'am.
Let's write it. And bp minus pt. bp, the total, minus pt will be bt is equals to bt. That's what we wanted to prove. I have written in the very beginning also, anti bt we wanted to prove, anti at we wanted to prove. Let me summarize everything. Okay, just a moment. So here we are having two chords which are of equal length. Both are intersecting with each other, and we have to prove that the corresponding segment after getting cutted, the corresponding parts of the chord will be equal with each other. Okay, that's what we want to prove over here. Okay, what I have done, taken over here, that here first thing first, we have dropped a perpendicular and then we are getting the middle point of the chord. That's what we have written. Then we have written that AB and MN chord are of equal length. Then half of AB, half of MN will be equal, and then from equation 1 and 2 we are getting the cases over. Okay, now we are doing one construction over here, and according to the construction we are saying that that triangle and this triangle both are congruent with each other. Once we are showing the congruency, we have got by simplicity that st is equals to pt. Now we are adding one time we are adding it with the equation number 3, and another time we are doing the subtraction. If in equation number 3 if you are getting confused, then you can write here you can write directly that half of AB is equals to half of MN. That means we can take uh, we can take from here that AP is equals to NS, equation number 3, and we can also take half of AB, that means BP is equals to MS, equation number 4. If that is not clear to you, you can take it like this: AP is equals to NS and BP is equals to MS. That's how you can take it. Okay. After taking this two equation, we are doing the subtraction. Let's say this is equation number 5. So one time we are adding 5 and 3, and another time we are subtracting 5 and 4, and then we are getting the result. Can we move ahead? Is it clear? Can we move
Yes,
ahead? Okay.
no, ma'am, it's not clear.
It's not clear. Uh, you can
No,
see
ma'am.
here. You can see here the theorem first. See the theorem. If two equal chord, we have drawn equal chord in the circle AB and MN. Of a circle intersect within the circle. We are having two equal chord. A circle we are having where two equal chords are there. Both are intersecting within the circle. Then we have to prove that the segment of one chord are equal to the corresponding segment of other chord. That means we have to prove that this one and this one are same length. The corresponding segment, the corresponding part after intersection are of same length. And we also have to prove that this is smaller one is equals to this is smaller one. That's what we have to prove over here. Okay, what we have done over here, we have we have taken center over here. Let just a moment. We have taken center over here. Let's say center O. We are dropping a perpendicular over here. We are dropping a perpendicular over here. This is point P. This is point S. Now we are getting, since we are dropping the perpendicular on each of the chord AB, we have dropped the perpendicular. So AP, BP will be same. Chord MN, we have dropped the perpendicular. That means MS, SN will be same because perpendicular from the center on the chord bisect the chord. This theorem we have discussed in the first class. Okay. Now we are saying that we have got that AP, BP same. We have also got that MS, NS same. We know that AP is equals to MN. That means half of AB is equals to half of MN. Okay, this was given to us. Now from here we are saying half of, just a second. We are saying that half of AB means this AB is half. Okay. We can take AP or we can take BP. Okay, so we are taking AP is equals to half of MN. Half of MN we can take NS. This is equation number 3. Clear? Similarly, half of AB and half of MN, we can also take BP. We can also take MS. And this is equation number 4. Now, we are having this two triangle SOT and triangle POT. We are proving these two triangles are congruent, and after proving it congruent, we are getting ST is equals to PT by CPCT. This is equation number 5. After getting ST is equals to PT, we are adding it with equation number 3. Okay. So we are adding equation number 3 and equation number 5. But be careful. If you will add ST with AP, ST with AP, you will not get anything. So we have to make the equation properly first and then we will be adding. So ST is equals to PT we have got. We can say PT is equals to ST also we can write it. Okay. Equation number 5 can be written as PT is equals to ST. Okay, because these two are equal with each other, so whatever way we will be writing, the left one we can write to the right hand side one we can write to the left hand side. It's still it's same. If the two persons are sitting on the seesaw, and here if a girl named Shreya is there, and here if Simran is there, then even though they will change their place, still they will be equal with each other, nothing will change. That's what we are saying. STPT same or PTST same. It's the same thing. Why we are doing reverse way? So that we can add equation number 5 and equation number 3 now. That PT plus AP is equals to ST plus NS. You can see PT plus AP is nothing but 80. 80. And ST plus NS is nothing but NT. So 80 is equals to NT. We have already proved. The bigger section over here of the chord is bigger section over there. Now we have to prove that MT and BT are same. So again, I am taking equation number. I would take equation number 5. I would take equation number 3, and we will be doing the subtraction. Okay, or not 3, 4. So we will be doing 4 minus 5. That means BP minus PT is equals to MS minus ST. Let's see what is BP minus PT. BP is total, PT is this much, that means the result will be BT. MS is this total, ST is this much, that means MT is this much. So BT is equals to MT we got. This is what we have to prove, this is what we wanted to prove, and we are done with the proof. Is it clear now?
Yes,
Is
ma'am.
it clear? Yes, let me know.
Yes, ma'am. Clear.
Okay, let's move ahead with the next theorem. Just a moment, let me take the next theorem. So the next theorem is three girls Reshma, Salma and Mandeep are playing a game by standing on a circle of radius 5 meter drawn in a park. Reshma throws a ball to Salma, Salma to Mandeep, Mandeep to Reshma. If the distance between Reshma and Salma and between Salma and Mandeep is 6 meter each. What is distance between Reshma and Mandeep? Let's see what the question says. Three girls, Reshma, Salma and Mandeep, are playing a game. How? By standing on a circle. Circle is having radius 5. Okay? Reshma throw a ball to Salma. Salma throw it to Mandeep. We are having a circle. We are having a circle like this. Reshma is here. Salma is there. Mandeep is here. Reshma is throwing ball to Salma. Salma is throwing it to Mandeep. And Mandeep is throwing it to Reshma. Now, what the question says? If the distance between Reshma and between Salma and Mandeep is 6, Reshma to Salma it is 6 meter. Salma to Mandeep it is 6 meter. Okay. What is the distance between Reshma and Mandeep? Reshma to Mandeep, this distance we have to find. Here, if we are having the center row, okay, we can let's drop the perpendicular over here. Now we can say that this is a chord RM. We can name it R is the, like we can name it R, point S. We can name it point R, point S, and point M. Okay, so that the name is there, but we are using the first letter for the point. Now if we will join like this and like this, okay, here also I'm just doing one construction. Let's see whether this construction will work on it. What we have to find here, we have to find the distance between Reshma and Mandeep. RM we have to find it. How we will be finding RM? Just a moment. Okay, let me see whether we, according to the question given, we have drawn the figure properly or not. Reshma to Salma to Mandeep, and then we have to find the distance between both are given. Oh yeah, radius is given as a 5 meter. Okay, this is the radius we can say here. Now here we are having one, we have dropped the perpendicular over here. Let's say this is the point, let's say X. Okay, now if we will focus on this two triangle ORS, ORS and OMS. This one. Is it possible to prove these two are congruent triangle? Yes, very easily we will be able to prove 6, 6 I can see over here, and you can see 5, 5 as a radius, and there is one common side. Easily by side congruency rule, can we say it's a these two triangles are congruent with each other? Can we? Can we?
Yes, ma'am.
Let's prove that. Triangle ORS and triangle OMS. We are saying that OR over there and OM over here is 5 meter radius. Okay. RS over there and MS over here is 6 meter. Both are equal. And OS over there and OS over here common. Therefore, triangle ORS is congruent with triangle OMS. And since these two triangles are congruent by SSS, can we say that this angle and this angle will be same. Let's see that angle ROS over there will be equals to angle MOS over here by CPCT. Getting it? Are you getting it? Okay. Now if we will take this two triangle ROX and triangle MOX, is it possible to prove these two triangles are congruent? Yes, it is possible. There we are having 5, here we are having 5. Now only the angle which I have written, that angle we want to prove this two triangle only congruent. But since only this two 5 5 will not give us congruency, that's why we prove that this angle and this angles are same. First we have proved the angle same so that we can prove ROX and MOX congruent. Okay, so I am using the angle case over here. I am going to say that OR over here is equals to OM over here, radius. OX is the common side and angle ROS over here, or ROS can also be written as ROX. Are you getting it? Angle ROS can also be written as angle ROX. Getting? Again, I am repeating, angle ROS can be written as angle ROX. Eventually, we are talking about this angle only. Am I making sense? Let me know, then only I'll move ahead.
Yes, ma'am.
So instead of ROS, I am writing ROX is equals to angle MOS can also be written as MOX. Which congruency criteria is working here? Side, included angle, and then side. SAS congruency criteria is working here, and hence we can say these two triangles are congruent with each other. Why we have proved the congruency? Now only I'll be showing why we have proved the congruency. So we will be saying triangle ROS X, no, ROX and triangle MOX both are congruent by CPCT. Oh, by SAS. Okay. Now from here, can we say RX and MX both are same by CPCT? Can we? RX, MX both are same. Can we? So if we have to find the length RM, then if we will be able to find only Rx, then we will say that Rx Mx both are same. If Rx I got, let's say 9 centimeter, 9 meter, then I would say Mx is also 9 meter. Why? Because Rx Mx both are same. And what we have to find? If we have to find the length of Rm, then we will do 9 plus 9, that is 18. This is just the assumption I have taken. I don't know what is the value. Let's find the value. 9 is just the, I have assumed. Okay, let's see what will be the value over here. We have found that Rx, Mx both are same. So if we will be able to find Rx or if we can find Mx, we will be able to find the total length by adding both of them. Okay, both are same. By adding the same number, again by taking the same number like that, the way I was saying 9 plus 9 or maybe 10 plus 10, we will be able to find the total length RM. Okay, so we are keeping this information aside, RX MX, and now I am going to take triangle ORX and triangle SRX. Let me take it over here. Let me draw the figure again. So far, is it clear to everyone? Then and only then we will be moving ahead. Let me know. Is it clear so far? Is there any confusion? No? If you want to see it again, you can see. First time I have taken triangle ORS and triangle OMS. From there we got the angle O over here, angle O over here is same. And then I have taken triangle ROX and triangle MOX. Eventually we wanted to prove that RX, MX both are same length. Okay. Or directly also we can say both are same length. Yeah. We don't have to do this much. Okay. Please don't do. We are dropping the perpendicular on the chord and that will bisect the chord. Directly we will be taking. Okay. Please don't do this much. We will say that from the center we are dropping the perpendicular and that perpendicular is bisecting our chord RM and hence RX MX will be same. Only this much we have to write. Please don't prove this much, the congruency and all. Okay. So we are saying that OX is perpendicular on RM and therefore RX MX both are same. Directly we are having one theorem which is supporting this part. Now let's see if we will take this two triangle ROX and triangle S, this triangle SXR. Okay, this one and this one. I am taking triangle this one and triangle this one. Okay, this two triangle we are taking. We will be applying Pythagoras theorem over here. Okay, we have taken that this is 90 degree, this is 90 degree. Eventually, this will also be 90 degree. So the sky triangle and the green triangle we are taking. This is from, we are just starting with this theorem. Okay, leave the previous part. That much we don't have to prove. Directly we can write Rx, Mx are same. Let's see when after taking this two triangle, is it possible for us to get to the conclusion what is Rx. So by taking triangle ROX, we can say that hypotenuse square, that is 5 square, is equals to perpendicular square, that is OX square, plus RX square. Okay. Now let's move over here. Here we can say in triangle. Okay, let's simplify the sky one first. So 25 is equals to OX square plus RX square. OX square is equals to 25 minus Rx square, or we can say that Rx square is equals to 25 minus OX square. Okay, this is equation number 1. Let's do the for the green triangle. So we can say in green triangle SXR or RSX, whatever you name it, hypotenuse square, that means SR square is equals to SX square plus RX square. Okay, hypotenuse square is equals to perpendicular square plus base square. Nothing else we have taken. Now SR, we know the distance between this one is 6. The distance between this one is 6. So 6 square is equals to SX square plus RX square. Again Rx square is equals to 6 square, that means 36 minus Sx square. We can compare both the equation 1 and 2, because in both the equation we are having Rx. So we will say 25 minus Ox square is equals to 36 minus Sx square. Now Ox Sx. Okay. We know that this complete OS is the radius of the circle. Can I say OS is the radius of this circle? Am I making sense to you? OS is the radius of the circle. Yes, we have joined center with any point on the circle, and that is radius. So OS means radius, 5 meter. Now OS is the combination of OX and SX. OS is the combination of OX and SX. That is 5. Like yesterday, now we will be replacing either SX or OX by using this relation. Okay, so I am going to replace that. I am going to take OX is equals to 5 minus SX. Okay, I am going to use it over here at the place of OX. Let me write it. Let's say Sx is x. Okay, Sx is x. Let's say. Okay, let's use it. So we will be having 25 minus, at the place of OX I am going to write 5 minus x is equals to 36 minus, at the place of Sx I am going to write x square. Let's simplify it. 25 minus 25. Here we'll be having a square minus 2ab plus b square is equals to 36 minus x square. We will be having 25 minus 25 plus 10x minus x square is equals to 36 minus x square. X square gone. 25 gone. We got 10x is equals to 36. X is equals to 3.6. X is what? Sx is 3.6. Sx, this much is 3.6, and total OS is 5. OS is 5. So from 5, if we will subtract 3.6, we will get from 5. If you will subtract 3.6, you will get 2.4. Okay? Or 1.4. 1.4. So this will be 1.4. Are you getting it? Are you getting how we got this 1.4? Yes or no? We have just taken sky triangle and green triangle, and we have applied Pythagoras theorem. We are solving it. Meanwhile, we have seen that two different variable was there. In a single equation, OX square came, SX square came. Then we realized we are having one relation, and the relation is this one. This relation we are using to just make it a one variable equation, and then we are solving it. We got x value as a 3.6. X is Sx, so Sx is 3.6. So OS, here we have written that Ox plus Sx is 5. We have written that Ox plus Sx is 5, that is radius. So if Sx we have got as a 3.6, then Ox will be 5 minus 3.6. Ox will be 1.4. Okay, do we wanted to find Ox? No. We want to find this Rx so that we can find the distance between Reshma and Mandeep. Okay, since we have got OX, easily we will be able to find RX again by using this is chi triangle Pythagoras theorem. Okay, so if this is 1.4, we can say that Rx will be under root 5 square minus 1.4 square. We have to do this calculation to find Rx. After finding Rx, we will say Mx will also be same, and hence we will add both of them and we will be getting our answer. Calculation part we will be doing together, but if let me know if the concept is clear or not. Yes, is it clear? We are dropping the perpendicular on the chord and we are saying that perpendicular will bisect the chord. Rx, Mx will be same. Now we are taking two triangle, the sky triangle, green triangle, and we are doing it just like yesterday. Getting it? Anyone let me know. Are you getting it? Ifra, Alvina, are you getting it or not? Okay, Ifra, yes, you are getting. Rest of the student, Reem, Galvin, are you getting? Yes or no?